The title of this talk and the quotation in yellow by the famous French writer Marcel Proust suggests that the right approach in physics is to have an eye for simple solutions based on first principles and to avoid engaging in improbable ad hoc speculation. The key point in this slide is that no mass external to the solar system affects the shape of its rotation curve. The Lagrangian is expressed with respect to the Sun, which is the exclusive gravitational potential producing this familiar exponentially decaying curve. This is M33 in the local group. Like numerous other spiral galaxies, its measured rotation curve is not just flat, but is accelerating to the limits of the observed H1 region. All of the observed mass in this image, including gas and dust detected at non-optical wavelengths, is not nearly enough to account for this rotation curve. Assuming that the anomalous rotation curve is produced by gravitational force acting in the same direction as the observed galaxy barycenter, one must then infer the existence of a vast halo of completely invisible gravitating matter, which defies explanation. Because spiral galaxy rotation curves are measured by slit spectroscopy, it is generally the case that the target is the only local galaxy visible in the telescopic field of view. The numerous other co-orbiting galaxies in the host cluster are not seen in this image simply because they are out of frame. When a spiral galaxy is observed in the context of its host cluster, it is clearly subject to a net barycentric gravitational force, which accelerates its intra-cluster orbital motion. It is equally clear that its disk is subject to gravitational tidal forces. Given a sufficiently long time of action, small differences in acceleration due to tidal effects in the disk induced by the external force Fc will have a large effect. Any simulation of galaxy evolution that ignores this effect is obviously naive. Seeing a spiral galaxy with new eyes means treating it as a dynamical system in the context of the host cluster. Given this gravitational context, which is completely different from the solar system, it is not possible to write a closed-form expression that describes the internal dynamical behavior of the disk. In addition to the rotation problem, any model of spiral galaxy internal dynamics must address the winding problem. The simulation seen here, which is based on the consensus density wave theory, demonstrates that the winding number of orbiting stars, gas, and dust, which has an empirical period on the order of 100 million years, is distinct from the seemingly static winding number of the spiral arms, which is on the order of 1. In order to be easily understood, a toy model must be simple, which means that it must have as few parts as possible. Our challenge is to model host cluster tidal forces on spiral galaxy disks. The orange ball, which may represent a gyroscope, has an idealized circular orbit with an arbitrary 12-hour period. The irrotational BCI frame is phase-locked to the ball. A co-moving observer would define this frame to be an inertial reference frame because it appears to be free of any accelerating forces on the orange ball. Here we have added 2 additional test masses of a lighter color. The 3 balls are slightly out of phase on the identical circular orbit and are defined to have negligible self-interaction. In a synchronously rotating frame, which is typical for artificial Earth orbiting satellites, the 3 balls do not change position according to a co-moving observer within the frame, which gives the false impression of an inertial frame. Because the synchronous rotation of the reference frame is correlated with the observed rotation of a co-moving gyroscope's spin axis, the reference frame is clearly not inertial. An inertial frame of reference is irrotational with respect to distant quasars. If the reference frame is inertial with respect to the orange ball, then one tends to imagine that it is also inertial with respect to any similar internal test masses if the frame is of arbitrarily small dimensions. This is a false assumption. There are no gravity-free environments. An inertial frame of reference is a figment of the imagination that can never be physically realized. Moreover, this simple demonstration implies a winding motion for any free-falling collection of particles orbiting an external barycenter. The winding period of these particles is correlated to the system's orbital period. Given the mutual acceleration of 2 1-gram masses at a separation of 6 meters, The resulting displacement over a 12-hour period is on the order of 1 micron, so the distant Earth is the only effective gravitational force acting on these 9 test masses. In the initial conditions shown, with Earth gravity denoted by F0, the fractional tidal force ratio between the blue ball at top center and the violet ball at bottom center is about 1 part in a million. An important feature of the computer simulation implementing our toy model is a slider control that provides the option to give the center orange ball a gravitating mass. The ball-centered inertial frame of our toy model is analogous to a galaxy-centered inertial frame as shown here. The initial conditions of our toy model imply that the test masses represent differential volumes of the disk, which encapsulate a dynamic mass flow orbiting the galaxy core. The modeled dynamic behavior of the test particles reflects the systemic behavior of the disk due to externally sourced tidal forces. This behavior is independent of the internally driven galactocentric orbital motion. These ideal experimental conditions might be implemented to close approximation by a real experimental spacecraft. However, because a computer simulation can very accurately reproduce actual empirical behavior based on simple mathematical rules, the simulation may serve in place of an actual physical experiment. To be clear, in our toy model, the Earth represents the gravitational potential of the host cluster, and the orbiting reference frame represents a spiral galaxy orbiting within this potential. The idealized circular orbit of the orange ball implies perfect knowledge of its dynamical behavior. Consequently, the software is designed so that the distinct accelerations applied to the 9 test masses in each iteration of the Euler integration are based on a corrected, perfectly accurate location of the reference frame. This elimination of global truncation error in the reference frame position, combined with the high precision of numerical calculations, produces an extremely accurate dynamical simulation of empirical test mass behavior implied by Newton's law of universal gravitation. This is an annotated image of the simulator interface. The software is freely available online and the code is open source. The left window will show the progression of the reference frame orbiting at GPS altitude. The right window is an interior view of that frame as would be seen by a co-moving video camera which records the motion of the 8 other test masses relative to the inertial orange ball at the center. The initial test mass spacing is 6 meters. The frame size is sufficient to show a radial migration of over 150 meters. At time 0, the 8 test masses are released into freefall from their initial locked position in the orbiting 3x3 grid. In both windows, the trace dots are being laid down at 10-minute real-time intervals. The monotonically increasing spacing between the test mass trace dots implies an accelerating rotation curve relative to the center orange ball. The highlighted graph indicates that the radial migration shown on the x-axis is correlated with a linear increase in velocity shown on the y-axis. The dynamical creation of the spiral structure, including the symmetric periodic morphology of the spiral arms, is correlated with the orbital winding number observed in the left window. If gravity could be studied empirically in much the same way that Faraday studied electromagnetic phenomena, this is exactly what would be observed. Given the fact that the identical physical principles apply to both systems, these remarkable correlations between our simple toy model and a real spiral galaxy are inevitable. The resulting morphology is correlated to the dot product of the disk's normal vector and the systemic accelerating force. In this case, the dot product is 0, resulting in a grand spiral. Surprisingly, the gravitational phenomenon revealed in the foregoing simulation is new scientific knowledge. The new explanation for observed spiral galaxy rotation curves makes no claim of particles with extraordinary physical properties and also explains the winding problem in terms of basic dynamical factors which are known to be empirical. The density wave theory was never considered to be a compelling explanation covering the broad variety of spiral galaxy morphologies. In short, a single compelling physical theory, which rests exclusively on first principles, replaces two different theories that are scientifically tenuous at best. Furthermore, recent empirical observations imply that no dark halo surrounds the Milky Way. This 2012 article in the Astrophysical Journal requires an explanation for the Milky Way's rotation curve that similarly does not depend on a dark component of its mass. This 2012 article in Monthly Notices of the Royal Astronomical Society points out that the standard cosmological model is in jeopardy, as it is strongly dependent on the apparently false requirement of dark matter for galaxy evolution. This 2013 article in Nature concerning Andromeda galaxy satellites corroborates the foregoing Milky Way observation. Host cluster gravitational tidal forces, implied by the manifest force vector Fc, induce dynamical effects on spiral galaxy disks that preclude a monotonic decay of their rotation curves. Accordingly, there is no need to assume the existence of a massive, completely invisible dark matter halo in the region of this image to account for the observed rotation curve. If such an unlikely phenomenon need not exist, then it clearly does not exist, any more than the luminiferous ether of the 19th century. The referenced work, which is a set of slides that dates back to September 2010, overthrows the fundamental premise of the standard cosmological model and consequently disproves the alleged independent evidence for dark matter. As of spring 2013, the facts this document conveys are not yet widely known. It has incited strong opposition from authorities who would apparently prefer that these facts remain obscure. I encourage critical evaluation of the existing gravity sim code and independent verification of this empirical phenomenon using new, more sophisticated computer simulations operating in 3 dimensions. Given that the winding number of spiral galaxy arms is correlated to the winding number of the intracluster orbit, the intrinsic age of a spiral galaxy can be approximated from its estimated orbital parameters. As also proven in the document referenced on the previous slide, this phenomenon implies that the prevailing standard cosmological model is completely wrong and that the age of galaxies and galaxy clusters is far greater than the age limitations imposed by the current paradigm.